Hello, in this video we are going to have a practical overview of the IPC concept and the methods available for this concept, which is quite very interesting and important in computer programming. So let's have a look at my resource monitor window, which is operating on top of the Windows 10 operating system. So we can see all the processes available in my system. So these are, if we go here, like if I go to CPU and processes, I can actually see all the processes that are doing some jobs and tasks. So these are actually every software that is performing some tasks and functionalities in my system. And we have also another parameter like working set, which is actually the amount of physical memory consumed by the memory. So for example, this is consuming 28 megabytes of memory right now. Now, let's go with knowing that what we are going to introduce in this video is going to be about the IPC or inter-process communication. So if I draw the list of the processes in my system, then the study of today's video is going to be about how we can make the processes talk to each other and how we can actually send the data from one process to another process. So that's the IPC is the topic of IPC, or inter-process communication. So how we can exchange data from one process to another. We have three methods of doing that. So the first method is called shared memory. The second method is called pipe method. And the third method is called message passing. So the shared memory, as the name stands for, is basically the concept behind the shared memory is by having a memory space which is actually shared by the processes. So if I take like P1 and P2 processes from my list and then try to have a shared memory which is actually attached to both of them, then I will be able to exchange the data from one process to another process, because this process could actually write information to a specific area, and this process, knowing that that memory has been written something, he can actually do the read operation and get the data. So that's the whole idea of IPC for the shared memory. So it's about having a shared space in the RAM, in the memory, physical memory, so that you can actually exchange the data from one to another. The second method is called pipe method. So this method is not applied on all the processes in my list, but it just can be applied on a certain processes in my list. So if I walk through these processes in my list, I would probably find that there is kind of the processes that are actually dependent, in a sense that they are created by each other. So this process, for example, could be generated before actually by this process, and this is very, very known in computers and in the processes and the systems software programs, that we have actually some processes that one is actually generated by the other process. So the generated process, we call it, as it's probably the name stands for child, and the generator process, we call it parent process. So once in a system we have a process which is actually generated by the other process, the new process is called child process, and this is called parent process. So the pipe method can be applicable for these kind of relationships, so the parent and child processes. So if I have a parent and child processes in my list, and I can actually take them off, so what I can do, I can put a pipe here and try to stream the data from parent to child. So I can then do the write operation to put the data into this direction, and then here just I need to do the read operation on this end of the pipe. So I put a pipe, and then I try to send data to this pipe, and the other process will read the data. So that's the whole thing. There is one point about this pipe method, is that it's actually unidirectional. So you cannot at the same time using it to send back the data from child to parent. So you cannot actually perform in this direction of the data operation. So if we, in any case, if we would need to do it, then we would need actually to put another pipe, and then try to attach this pipe, this actually end of pipe, to the write operation for the child process, and this for the read operation. And then this is going to have a bidirectional communication between the parent and the process. So the point here is about having a unidirectional process communication. So this is also the second method that we described in this section. Let's go to the third method, which is the message passing. So in the third method, we are not really dealing with the memory and with really read and write operations. So it's more abstracted idea in this case, in this method. So if you imagine a software A and a software B, so that they actually want to send information or the messages to each other, as the user program, so it's actually A and B are the user programs, so me and or you or everyone who wants actually to implement a code, who can write the A software and or the B software and try to send the data from one to another. In this case, what I probably would need to have is just, to have some models, let's say, and objects and names and the name of probably destination and then source that could probably resolve my problem. So like this message passing system is based on a software which is actually making you to write your program and to use those APIs to actually send the messages to another software. So the memory and read and write is handled and controlled by this lower layer of your program. So what you need to basically to do and to make is just to make kind of the object-oriented programming model. So you need basically to know that, so that you can go further and make the program work and design a destination, design the objects and define the objects and the functions that actually can be called remotely from the software A within the software B. So you can actually do some remote actually sending information from A to B, and the inter-process communication will happen. So this is actually more abstract, and you're not really dealing with the memory and the lower layer stuff. So you actually, as a programmer, you care about the objects and the names that exist in your system that you have defined, which is actually for you, and you can actually be using. So I think that's fine for this section. So let's go introduce the next section, which is more practical implementation. Thank you for this part.